Well, I mean, so if you look at the stats, the numbers will say, well, the U.S. workforce needs to tap into all of its different ethnic and racial minorities, right? That's what the stats will say. But what's really more important is that the data also show that the most important teams that solve the best problems are the most creative and the most diverse. That's another sell point for people. But what I really think is important to say, economic advantage, STEM jobs pay the most, they're always hiring, you develop your skill set, you develop your expertise, people want you, people look for you, and people overlook that. But the other important reason that we as people of color also need to be involved is there are things that affect us, health disparities and diseases and many other things that really impact our community, that how are you going to convince someone else to care about it, right? But if you care about it, you can go out and find answers to those questions, and then you can impact your own community. And that is why I think a lot of these things become health disparities. And the big thing, I do a lot of health disparity research, and what's become obvious to me, things that are health disparities in the United States are global health problems. So the minority communities here are suffering just as much as these developing countries that we talk about in other places, but it gets ignored in the US context because we're a rich country. So you see a problem, you go out and you learn how to solve it, and then you bring that community together. And that's where I think we really add value. So when they first have trouble in math, don't tell them math is not important. Tell them to push through, right? We fall out at several different points on the pipeline when things get a little harder than what they normally were. Support that child through that math, support that child through that science. That's the first thing. And then I think the other parts they really could do is really seek out Black mentors and role models in their community, their schools, there's civic organizations, Black men, 100 Black men, 100 Black women. Like, there's all these places where role models are, but it's about tapping into them probably. And I know that can be difficult because maybe they don't know where to find them. But the web is everywhere now. This series will be on the web, and they should really just tap into that their young people can see very early on, oh, people like me do things like that. And it really takes away the whole mystery of what's over there and what are they doing. And at the same time, listen to the mentors. I had some great mentors and role models on my career, even from a youth. And it's one of those things, they present something to you that you didn't even know was an opportunity, right? Because you can't say, oh, I'm gonna go do that because I know how to get there. Like, we don't know how to get there, right? But as when someone presents an opportunity, though it's scared, like, jump on it. Because a good mentor will not put you in a place to be in trouble, right? And I think it's that, not being fearless, but being a little bit unafraid to just go out there where someone pushes you somewhere new and somewhere different. Because if they're doing it, it probably gonna have a great payoff on the other side. And I think that's what parents can support their children through those difficult moments. That when you're learning science in school, it's you get the right answer or you get a bad grade. And as we know in real life, scientists in the lab, we don't know the answers, right? If you know the answer, there's no need to do the experiment, right? It's interesting because, this is a really good question. I think about it, even when I have my graduate students that start with me, right? So I'm in a biomedical engineering department. Engineers don't per se learn the scientific method the way scientists learn it, right? I was trained as a scientist at Morehouse. And so they're scared to have a hypothesis because they want to know, I want to know what the answer will be before I make a hypothesis. And I'm like, let's back up. Hypotheses can be wrong, right? We test them. We don't prove them, we just test them. And it's funny because even at their age of 22, they finish an undergrad degree, are still quite scared to be wrong. But as we know in lab, we're wrong probably 67% of the time. 2/3 you're wrong. But when you're right, it is sweet. Not that anybody believes you until you show it again and again and again. But that's something I had to think about. How do you teach that in an early age that it's okay to be wrong? Because the grading system that we use doesn't support that, right? I don't have that answer. The pedagogical people who were giving talks earlier, they may have a better chance of that. But I definitely tell my lab group, like, it's okay to be wrong if we have a reasoned hypothesis and we ask the question with an experiment that will answer that question. Then we can figure out the answer. But if we already know it, we're not even gonna do it. So like, just forget about it. But the other thing that's exciting, right? What we do in the lab, I tell my students this too. We are putting or developing knowledge for textbooks, right? Like everything that we've read about, that person didn't know it when they started, but they did experiments, they found it, everybody believed it, they put it in the textbook that you learned when you were in school. So what we're doing is making stuff that is gonna go into textbooks, which then they're like, huh, which also seems daunting, but it's also like, well, I can stick my chest out a little bit to that. So yes, big challenge, but failure is a part of learning and a part of science. It's a part of it, yeah.